Okay, so they give slope fields, give a picture of possible solutions to differential equations. So far, I've put this one here because there's only one type of differential equation we know how to solve right now. And that is a super simple one, like what we have here. I did do this just a little bit for notation purposes. You technically would have to multiply both sides by dx. Oh no, what's he need? Yeah, that's fine. I don't know. No problem. Johnny, leave my door open? Or okay, all right. Okay. All right, so we've got we could have like 50% fewer incidences to report if only Daniel would quit bullying. Okay. All right. So if I have this 8x plus 4 dx, and a lot of you guys, whenever you're integrating, you're leaving off the dx every time. I realize it feels like it does not do anything, but especially with differential equations, it's really important that you write it. So, yeah. So if I integrate both sides now, integrating dy just gives me y. And then integrating 8x to the fourth here, we're just doing that simple power rule. So x squared, 8 divided by 2 is going to give us the 4 out front. And then plus 4x, and what do we put on the end? Plus c. Okay. So this is the only type of differential equation that we know how to solve right now. Is a differential equation that we can just multiply both sides by dx and then just integrate really simply. Mm-hmm.
Solving it just means putting it in terms of
It means that you are going from this dy dx, which means you have a derivative, to having y equals, which would be the integral of that function. So whenever you have a derivative equal to something, that's your differential equation. Whenever you solve that, you solve it for the y, which you do by integrating. Yes. Okay. So now, whenever we think about what this looks like, it is not one graph. It is many graphs. Because of that c. So y equals 4x squared plus 4x plus 0. But it also equals 4x squared plus 4x plus 3. And it also equals plus 7. Yes. Minus 5. All of these are what we would call solution curves. And you have an infinite number of these. There are an infinite number of solutions. Because I could keep doing this forever. Minus 8 or plus 8. Let's do one with the minus 10. Like eventually it would fill up the whole entire screen and continue on to infinity. It just is automatically putting different colors in there.
You can put like A and put a bracket. So infinity, like all decimal numbers. And then you put C and you put it in brackets. Oh yeah, do a slider, Infinity. Oh, that's awesome.
Is it working? Oh yeah.
That's how the theory goes. Could you do that thing? It looks like the theory goes.
Anyway, so quiet please. Focus up here. Alright, so you could have all of these possible solution curves. So when we're just integrating something with a general solution, we have infinite number of curves. So a slope field is something that's going to help us get a picture of that. And you can make a slope field for any differential equation, whether you know how to solve it or not. So right now we don't know how to solve very many equations. We are going to learn how to solve first order separable equations, but there's lots of other types of differential equations that we won't even learn how to solve in this class. So let's talk about what it means to draw a slope field. And this is a little bit tedious. We could solve this one first because this is one that we do know how to solve. But I'm not going to yet anyway. But I guess if we wanted to, we could solve it just to see what the solution is. So to do that, you would just, the dx has to be over here. That's kind of a formality there. And you would integrate both sides. So the solution to this should be x squared plus x plus c. All right, so we do know how to solve that one. But that's an infinite number of curves. To make a slope field, this is what you are going to do. Your derivative equals 2x plus 1. So whenever they may ask you on the AP exam to draw a portion of a slope field. It'll usually be very small, this size or smaller. That they're only asking for a few points just to see that you know what to do. It's not going to give you a very good picture, but it'll show you what to do. Or they may give you a picture of a slope field and ask you questions about it. So all we have to do here is we're going to take these points that we have. So all of these points, we're just going to take them and plug them in. So for example, you could go, one by one. So if I have, I'm going to make myself a table here. If I have x, y, so this is the point 0, 0. So I'm looking at this point right here. So dy over dx, you're just plugging into this equation. So it would be 2 times 0 plus 1, which would give us 1. So what you're going to do is you are going to draw a tiny little slope that looks like it has a slope of 1. All right. So then I could try the point. I'm going to use a different color so you know which one I'm talking about. I could do 0, 1. But does this equation have a y in it at all? So I'm still going to get 1 for that one. And so you can sometimes you can see some patterns where you're like, oh, well, if my x equals 0, then the dy dx is going to be 1 for this entire vertical line right here. So we would have all these little pieces here. Let's go over here to the point 1, 0. And so if I plug in 1, 2 times 1 plus 1 is going to give us 3 for that slope. So whenever you do this, I need a slope of 3. So it'd be like if I was counting up 3 and over 1, so it would need to have this slope about like this. When they grade this, they're grading them relative to what you have drawn. It doesn't have to be perfect, but your slope of 3 right here should be steeper than your slope of 1. Yeah. And then so the same thing's going to happen here for this problem. All of those points in that vertical line are going to have the same steepness. We're just doing little tiny pieces. These are little tiny tangent lines, possible tangent lines is what we're drawing. On the SAT? ACT? I would like to see that. Because ACT is not supposed to. I have heard that before. Actually, somebody else has told me that was the case, and I don't know about that because it's calculus is not supposed to be on there, so I'd like to see what they were asking about it. And it might be one of those things, sometimes they put...
It wasn't this, it was like example 3.
Right. Sometimes they will put questions that are advanced in something you don't know, but they'll give you enough information that you can read it and understand what to do from that. So it's possible that was the type of question they're giving you, but I don't know.
Example 3 on
Yeah.
Some tests have like a certain number in there just to see how far, like if they even know the material, but it's not very good.
That could be field test items. They do put, yeah, they do put those on sometimes, but I don't know why they do that with that. So, all right. No, you don't know which ones are field tests.
Like the 30 question quiz that they always give you that they don't say is for a grade, they just want you to do it. On the ACT.
I don't know if that's usually on there.
That's the one I had to take. I took my 4 tests, and then at the end they said, you're going to get a random test, you don't know which one it is. Take it.
I don't know. That's never happened to me. Those could possibly be field test questions. I don't know. I've never had that happen to me given the test
Like
here. So
everybody in the room, like I got a math test, person next to me got a science test, somebody else got a reading test.
I bet those were field test items.
That's not a cheat, obviously.
All right. All right. Quiet. All right. Focus up here. All right. So if we plugged in the 0.20, we would get a slope of 5, which is going to be super steep. We just need to try to make it look not quite vertical, but also not quite vertical, but also steeper than the ones next to it.
Then you can mirror that on the other side.
Nope. Not necessarily. It might, but you got to plug in the numbers to see for sure.
-1.
So in this case, I think it actually kind of will. It's not the exact mirror, because here if we plug in -1, we'll get a slope of -1. All right, so we would have a slope of -1 here, like that. And then if we plugged in -2, 0, we would get a slope of -3. And so you can sort of start to see here that those solutions would follow some sort of path where they are looking something like this, which would give us a parabola of some sort. So now slope fields are more helpful when you have more points, but of course whenever you're drawing them by hand, they're not going to give you that many. For this, I think, let me look up the Desmos slope field thing. So Desmos has a slope field generator where you could type in your, it would give you a much better picture to x plus 1. And so you can see they'll give you more points. I don't know that that's actually much more helpful, but maybe a little. So it's much easier. Like if you want a really good slope field, you're going to use technology to come up with that. But they do want to know that you know where that slope field comes from, so they will sometimes ask you to give, Daniel, quiet. They will sometimes ask you to give, just points, a few points, so they know how to find it. All right, so here is one we can't solve. Yes. We did not have to solve that. We just had to draw the slope field. This is one that I don't know how to solve.
Well, you see, you'd have to.
I'm just looking at the note about Jack figured it out.
Yeah, I mean, the slope field you can draw, certainly. Yes, you can, all right. You can definitely draw the slope field.
Yeah.
When I say solve, Daniel, quiet.
I think I could.
Okay, so probably could. All right, so when I say solve, I mean move the dx over and integrate, because if you move the dx over, you got this y over here that is in the way. So you can't solve this. This is not a separable differential equation. You don't know about those yet. I will teach you later. But even after you've learned everything that we're going to learn in this class, you still don't know how to solve this one. So all you do for this, now, if I have the point 0, 0, my slope will be x minus y, which will be 0. So a 0 slope is a horizontal slope there.
How do you draw the line if it's black?
They will usually, they'll print it much lighter. Yeah. Yeah, so I was just solving this to show you kind of what it looked like. But for slope fields, they usually will not ask you to act. Well, if they ask you to solve it, it'll be at FRQ. It'll be at the end. But to draw a slope field, you don't have to know how to solve it at all. You just have to know how to plug in points and draw little slope lines. So it can take forever sometimes. Because, like, if I try the point, I'm going to do 1, 0, 0, 1 here. So 0 minus 1 is going to give me a slope of negative 1. If I do 0, 2, that would give me negative 2. So that would be a little bit steeper there. If I did 0, negative 1, what would I get? Positive 1. If I did 0, negative 2, I would get positive 2. And now I'm going to move on. So I've got 1, 0. 1, 0 would give me a slope of 1. It might actually be helpful to do, let's do 2, 0 next. 2, 0 is going to give me a slope of 2. So if you kind of look at what's happening here, like if we do 1, 1, 1, 1 would be 0. And then, because doing this can take forever, you want to kind of look for patterns to help speed up. If I do 1, 2, that's going to give us, hold on, did I really mean 1, 2? I meant to do 2, 1. I get my x's and y's mixed up when I'm doing these so bad. 2, 1. So 2, 1 would be a slope of 1. If you kind of look at what's happening, the slope here was 0, then 1, then 2. Right here it was negative 1, 0, 1. So if I've got negative 2, this one's going to be negative 1, and then 0. Yeah, so our diagonals right here are going to have the same slope. It'd be even steeper here, so you got like 0, 1, 2. This is going to be 3 and 4. This would be negative 1, 0, 1, 2, 3. I realize my lines look terrible. You would have here negative 1. These are going to be, no, wrong spot. Negative 2's go here. You have negative 3's here. Negative 4 here. Typically, on an AP question, they are not going to give you. They're not going to give you quite this many points. It's usually they might give 6 or 9, maybe 12 at the most points. And a lot of times they will grade it to make sure that you have your 0 slopes in the right place and that all of your other ones look similar. So if we think about what these graphs would look like, so if I started here, it's got to sort of go with the flow of the graph here. So if I had something that maybe looked like this, oh, let's change into a straight line. Maybe something like this. It's eventually going to have to turn back up and go along here. Or if I start from down here, I would turn to a straight line. I would have a curve that goes here. Your graph is, you guys get the picture of what I'm trying to do there. Your graph is going to have like a slant asymptote along this line.
Like on example 3.
This is a slope field for the situation. Right. Now, you're right. This slope field looks pretty much like the slope field we just saw over here. It's just drawn a lot more beautifully because it's done by a computer and not by a person. So it says the slope field for a certain differential equation is shown above. Which of the following statements about a solution y equals f of x to the differential equation must be false? So first it says the graph of a particular solution that satisfies f of negative 3 equals 2. So let's graph that point. Negative 3, 2. Negative 3, 2 is right here. It's going to be concave up. So if I try to draw something in here that kind of follows the pattern of what's happening, is it concave up?
Yes.
Yes. So it is true, so that's not the answer because it asks which one's false. Now it's asking me about the point negative 2, 2. So negative 2, negative 2, which is about right here. All right. Is that going to be a minimum?
No, it's not a negative 2. It can't go past. It can't go to
It looks like right there. It looks like I've got. I'm going to switch to a pen instead of the highlighter. It looks like right here. It looks like I've got that horizontal tangent line somewhere around there. So it looks like it's probably going to have a minimum at that point. So probably not B either.
If it was negative 2 or positive 2, it would have been false.
Correct. Yes. At 0, negative 2, 0, negative 2, the graph is concave up. If I follow what's happening here, I think that's going to be concave down. I think this is going to be my answer, but let's check D just to see. 1, 0. 1, 0 is right here. Is that solution linear? Yes. Because it would fall, all those, it would just be that line. So it's not that one either. Okay? All right, so I want you guys to look at the last two for me over the weekend. So this one is just another type of question. This one, at least try to draw the slope field. You don't have to answer part B, but at least try to draw the slope field. Yeah, so slope field is just plugging in numbers.
But it's not like the lines. Like it's not.
Right, it's not on lines, just at the places that have points. And this is an example of like what you'd see on the AP exam. This is about how much they'd ask you to do on the AP exam.